Welcome to our presentation, Pointcloud registration with dense semantic features for robotic tabletop manipulation. 3D scene understanding is an important aspect of robotic manipulation, as the agent directly interacts with the object in the 3D space. Typically, a 3D scene is captured by scanning the scene from multiple viewpoints and then registering the scene using the post-transformation between the viewpoints. However, in the real world, these post-transformations are often unknown. Methods like iterative closest point and bundle adjustment are then used for estimating the post-transformation. Recent works incorporate models trained on a large-scale 2D dataset to enrich 3D representations by adding semantics captured from 2D to the 3D space. In this work, we aim to leverage such semantic cues from the foundation models to improve point cloud registration and using these registered point clouds for real-world robotic manipulation. We first capture the scene from multiple viewpoints using an RGBD camera. Next, we use DynoVIT, a transformer-based model trained on a large-scale 2D data to find pixel-aligned features that are then projected to 3D. These features are then used to compute correspondences between the viewpoints using best buddies pairs. Now, we use different registration approaches, including Karp's Umeyama and Arun's algorithm that gives a deterministic solution in one step, assuming that the given correspondences are correct. We can then run ICP using the transformations predicted by the two algorithms as an initial point. For a single object, we observe that Umeyama and Arun's method registers around the primary object of interest pretty well, but the simple geometric alignment, like the table, suffers. ICP, on the other hand, only focuses on the larger object, the table. ICP, followed by Umeyama and Arun's initialization, overcomes both the drawbacks and achieves a perfect solution. ICP is known to primarily suffer in challenging viewpoints. ICP registers the table perfectly, but the cups are completely flipped. Again, Arun's method serves as a great initialization for ICP. In case of clutter, however, the variety of objects provide a rich array of semantic cues which helps Umeyama and Arun to achieve a perfect solution in a single step. Here we show another cluttered example where Arun and Umeyama achieves a perfect solution in a single step.
We show some examples of real-world manipulation using our framework. We use our technique to register the robot's view to the scene point cloud. We then segment the object of interest using an off-the-shelf segmentation algorithm and project it in 3D from multiple viewpoints. The brass points are the points on the border of the bounding box of the object in the 3D space. As can be seen, our approach is real-world ready. However, we do encounter some failure cases, like when the registration is not perfectly accurate, or when the brass pose is not estimated perfectly.
In conclusion, we present an approach to improve the point cloud registration using deep semantic features from models trained on large-scale 2D datasets. Importantly, our approach directly works in the real world.